Okay, so here is a probability review problem. It says a tire manufacturer designed a new tread pattern for its all-weather tires. Repeated tests were conducted on cars of approximately the same weight, traveling 60 miles an hour. The test shows, evidently I didn't capitalize, here we go, shows that the new tread pattern enables the cars to stop completely at an average distance of, okay, so we see a couple of important things. Average distance, okay, standard deviation, okay, and the stopping distance are approximately normally distributed. All right, so it says, what is the 70th percentile? So we're looking for an X value. And so we're not looking for the Z, we're looking for the X value. I'm going to show you a couple of ways to get full credit for this on an AP test. The first way, and I think this is probably the safest, is to show how you're getting Z first and then using a formula to plug in Z and finding X. And then I'll show you a calculator, but there's a couple of warnings when you do it on a calculator, because what I'm noticing in my students, when they use their calculator for probability, not a lot of them are putting everything they need to put to get full credit. So we'll talk about that in a minute, but here we go. So we need to find this Z. Okay, let's find the Z. We can find the Z one of two ways. Here I'm showing using the inverse normal in a calculator. And of course you can use the table, the Z-score table. What you do is you look for that area, this 0.7, get the closest you can to 0.7 and estimate your Z-score from that. Or use a calculator inverse norm. Okay, one of those two, find Z. Now we're going to use Z to find our X value. Okay, so Z, that's a Z. It's a funny looking Z. Here we go. So Z equals, so we have the statistic minus the parameter over the standard deviation. Okay, and so the statistic, make sure you don't go parameter minus statistic. Statistic minus parameter. Okay, and that the statistic, that's what we're looking for. So we'll call that X. Okay, that's our X value. Minus the mean, right, of the population. That is the parameter. Wow, it took me too long to figure that word out. Okay, and then 6.5 down here. Okay, and so then we use that formula. We use that formula to find Z. To find X, because we just found Z. So we take out the Z, put 0.52, and that's how we're going to find X. Okay, and so when we rattle out this and just do a little algebra to this, find X, we get 128.4. But let's use the context, and it's in feet. So make sure you write 128.4 feet. Now, if you're using kind of going the calculator route, let me show you something real quick here. Okay, so we're going to use inverse normal, but here's what you need to have to get credit for all this if you go right to inverse normal, which you can because you're given enough stuff. You're given average distance right here. You're given standard deviation, right? You're told that it's normally distributed. So you can go right to inverse normal. And when you do that, you have to have a couple things. One, make sure you have a drawing here. Oh, and label your drawing. Tell what this distribution of stopping, probably be a little bit neater than I'm being right here. Stopping distances. Okay, you want to label what the heck we're looking at there. Okay, and label where the X is. Put a shaded region. Label that as 0.7. Right. That's telling the reader that you know what 70th percentile looks like, what it means, and so on. Make sure you put 125 here because that's the mean. So what the readers are looking for when you use this, two things. One, this diagram that's labeled and everything, and then you got to label all these things. You got to say what all these are. That's the probability, or that's the area. Okay, also shown in my diagram there. And then of course the 125. That's the mean. Okay. And use the right symbols. Remember, the mu is the population mean. X bar is a sample mean. And this is standard deviation. I'll call that sigma. Okay. And then when you put your answer as what is it? 128.4 feet. Make sure you label feet. Okay, that was one of the things in the rubric. The rubric, check this out. You're told that it's on that. You can actually Google that. You can find the rubric of this. Okay. And so you can see exactly what they're looking for. It's just sometimes there's a whole lot of stuff in these rubrics, and it's just kind of a big mess sometimes. It takes a minute to find what you're looking for, perhaps. But that's what we're looking for in this one. Let's go to a calculator. I want to show you something real quick there. So in the Inspire, we'd go to menu. We got statistics. Probability. Distributions. We're going to go inverse normal. Boom, inverse normal. Okay. Now, excuse me, there's three things there. So the area, we know that that's 0.7. Now, if we keep mu as 0 and sigma, the standard deviation, is 1, then we're finding the z. Okay, that's actually what we did at the first method of how we did that. Okay, but we can actually find the x value because we know the mu is 125 and the standard deviation is 6.5. 6.5. Okay. And boom, there's 128.4 feet. Excellent. Let's take a look at part B. What is the probability that at least 2 cars out of 5 randomly selected cars, let's see, 2 out of 5 randomly selected, will stop in a distance that is greater than the distance calculated in part A? Okay, so we're looking for probability. Now, we can do this in a calculator, but a lot of times what I see is not enough work on there. So here's the work. Here's an example of the work we need to show here. In other words, we're finding the probability that x is greater than or equal to 2, so that's at least 2, greater than or equal to 2, and the thing we calculated in part A was 70 percentile, so 0.7 is the probability of success. Okay, so if you don't remember how to write the equation out for this, it's actually in your packet. Okay, that's a formula that's written out in your packet. And one thing I noticed in my my class is that some of my students that used a calculator didn't label everything correctly, or didn't label everything that they were supposed to label, left some things out, and got some points taken off. If you use the formula to write out all this, the AP readers don't really care if you use that formula to find the answer or you grab your calculator, but they do want you to understand how this all works, okay? And so let's use the formula. Now, I'm going to go right into the greater, at least 2. I'm going to say 2 or 3 or 4 or 5. There's actually another way to do it. You can, this is the idea of the complement. So it's 1 or 100%, right? 1 minus the probability of 0 or 1. Car, right? And that's the same thing, but I think this is a little more straightforward. So 2 or 3 or 4 or 5. Okay, kind of a long thing to type in your calculator. Good news is you don't have to type all that in, but you do have to show the AP reader that you know what the heck you're doing. Okay, and so we use that formula from the packet, and we start off with 5 choose 2. Now that's combinations. Really what that means is how many different groups of 2 can I make out of 5? And that's for the positions of my 2 successes out of 5 trials. Okay, if that didn't quite make sense to you right now, that's actually okay. But that's what's happening. Okay, and then we have the probability of success here. The probability of success is actually 0.3. I think I said 0.7 earlier, but that was because of greater. Okay, so greater. So remember when we had this, Okay, and this was 0.7. Well, that's nice and neat. Okay, here we go. And so that would be 0.3. Okay, so greater, that's the probability of success. Okay, all right, so then it's probability of success squared because we have two successes. Remember, 2 or 3 or 4 or 5. So or in probability, we add. And so we have 5, choose 3, and then the times the probability of success, 3 successes, probability of failure, that'd be 2 failures there because out of 5 total trials. Then we got 5, choose 4, 5C4, right? And then we got 3.3 to the 4, and then 0.7 to the 1, because if we have 4 successes, we have 1 failure out of 5 trials. Plus, and here's our last one, 5 choose 5, which is 1, because really what that's asking is how many different groups of 5 can you make out of 5? You could make one group of 5 out of that, okay? But right now, who cares? All right, here we go. 0.7 to the 0, that's also 1, but who cares? Okay, so now we're going to type this into our calculator. All right, so binomial CDF. So we go menu, get to a calculator page, and then go menu, probability, what are we doing? Oops. That's not what we're doing. What the heck was I doing there? Okay, so probability distributions. And we're going to use binomial CDF. Where's binomial CDF? There it is right there. Binomial CDF. Okay, so binomial CDF. Here we go. So make sure that you put enough work to show, okay? And now you can type all that junk in your calculator. This is way easier. Please do it this way. Here we go. So we have n. We have n is, what was that, 5? 5. And then we have the probability of success, which is 0.3. And the lower bound, okay, the lower bound, it was at least 2, right? So 2. And then the upper bound would be 5. So 2 or 3 or 4 or 5. Boom. And then we hit OK. And there is our probability. If you want to round to 4 decimal places, for whatever reason, sometimes we do that. It's 0.4718. There you go. There's your answer. Excellent. Let's move on. Okay, part C. Yeah, it's kind of a long video, but here, let's see if we can get part C. Okay, here we go. What is the probability that a randomly selected sample, so catch on to that. What is the probability the randomly selected sample of 5 cars in the study will have a mean stopping distance of at least 130 feet? Okay, so we're talking about a sampling distribution of sample means, if you remember what to do there. Okay, so it's the probability, x bar, that's the sample mean, is going to be greater than, at least 130 feet, so greater than 130, okay? And because we're going to use a normal distribution, we're going to use a z, and so we have probability that z is greater than. Now here's our test statistic, right? And in your packet, it tells you how to get the test statistic. It's the statistic minus the parameter divided by the standard deviation. Well, if you don't know the standard deviation of the sample means, good news is that's on your packet too. That's on your formula sheet. So get used to your formula sheet. Make sure you know what's on there for the AP test, okay? Because at this point, we're still assuming that there's going to be an AP test this year. Okay, so here we go. So we have z is greater than, we have the, let's see, 130, okay? That's the statistic minus the parameter divided by the standard deviation, which is this, okay, divided by the square root of 6.5, divided by the square root of n, right? And n is 5, okay? So at this point, you have P, the probability, that's way too thick. All right, here we go. So we have the probability that Z is greater than, be careful when you put this in your calculator, okay? Numerator divided by denominator, be careful with that. And we're looking for, what is that, 1.72? Okay, so now we're either going to use a table or your calculator, Go ahead and finish that. Have a wonderful day. Hang in there. Keep working hard. Email me if you have any questions. I will see you later.